Welcome to a new presentation. This presentation is going to be on creating an RSLogix500 microlight simulator. The software is actually titled RSLogix Microlight, but that software is RSLogix500. It's just a version that will only support the RSLogix1000 and the RSLogix1100. A brief explanation on my interest in this software being used as a simulator. Some years ago, I developed a PLC learning system that used the 10-point RSLogix1000, which was the least expensive PLC that you could buy that was programmable with RSLogix500. And Rockwell Automation has had a free version of RSLogix500 available for quite some time. So the idea was to give the student a system where they could use the least expensive PLC that you could buy for roughly $100, and then that's a 24-volt DC version, and you need a power adapter which you could buy for $10, and 6 toggle switches which you could buy for another $10. So for under $130, $140 you could build yourself a hardware training unit. And I wrote lab projects for all 70 or so instructions available with the RSLogix1000, and it ended up to be a fairly fat manual. So because of the cost of printing in color, it was going to cost, and still does, probably $35 to print a document that size in color. So I broke it up into 3 manuals, and although the cost is a little more for the 3 than one big one, a person could buy the basics manual, which had the basic, what I call the 5 originals: true if on, true if off, latch, unlatch, and maybe had a timer in there. So a student could buy just the basics manual, and then if they liked it, then they could buy the other 2, because a lot of people are hesitant to spend $50 on a set of manuals when they have no idea what they're getting. And this didn't work out really well because it's still fairly expensive. So make a long story short, I decided to no longer offer just the printed manuals, but to offer the PDFs in electronic form. And people buy those on www.plcprofessor.com. Then I send them an email with the 3 PDFs attached. Well, the RSLogix1000, great little PLC for the money, very versatile, but eventually it will be put into what's called the Silver series by Rockwell Automation, which means that they see a date sometime in the future where it will go into a legacy, meaning it's no longer going to be manufactured. There'll still be some replacement parts, possibly, and there will always be places that repair them. But for a $100 PLC or $125, really, you're not going to get it repaired for any less than what it would cost to buy something else new. So seeing this RSLogix1000 having an end to availability, and they are still available, I just ordered one yesterday, but looking ahead, I wanted a simulator to replace it. So that's what this presentation is about, is using available software that's available free from Rockwell Automation to create a simulator. Okay, the big question is going to be, what is RSLogix Emulate 500? There's 3 pieces of software needed to create this simulator. You need RSLogix Microlite, that's the programming software, and then you need something to connect it to a PLC, or in this case to the Emulate software, and that software is called RSLinx. So RSLogix Emulate 500 is a application that emulates processors that can be supported or programmed with RSLogix 500. In this case, it's only going to be the MicroLogix 1000 or 1100. Okay, so here's your, we'll call it your computerscape. You have two computers. You have a desktop or laptop, we'll call it the PC, and you have a PLC. Now this is without using Emulate. This is the standard conventional way to learn to program a PLC. You need a computer to run RSLogix 500 and RSLinx on, and then you need a PLC to download to that has some switches on it that you can flip and exercise your program. So you see two pieces of RAM here. In the PC, the RAM is kept alive by the power from the power supply. In the PLC, it might have flash RAM, it might have EEPROM, most likely it's battery backed. So the first thing you do in your laptop is you load RSLinx. RSLinx is a driver manager, very similar to a printer driver manager in your laptop or desktop. Most of us probably have Microsoft Office, or we have Open Office. Either way, we have a word processor, and we have a spreadsheet, we might have a publisher. When we create documents and we want to print them, we may have to print them on different printers. I have two different printers, actually three different printers in the house, and each printer requires a different format for the data coming from the Windows software, whether it's OpenOffice or Microsoft Office. The printer itself has unique requirements for the form that the data arrives at the printer. Hopefully, when you print a document from Microsoft Word to 7 different printers, all 7 of those printers print out identical documents, ignoring quality of print or vividness of the ink, but the basic document should look identical. However, each of those printers requires its own unique driver, and the driver fits between the application in Windows and between the device out there, in this case the printer. RSLinx is a driver manager. The first thing you make note of on your PLC is what serial ports are available on that PLC. Most PLCs have 2 serial ports, probably RS-232 and Ethernet. In the case of Allen Bradley, it's going to have RS-232 and DH45 or DH Plus or Ethernet. Some of the newer processors, it's going to be RS-232 and or Ethernet. Your computer, of course, is going to have more than needed communication ports. So your computer is probably going to have RS-232, Ethernet, and USB. Not all computers have RS-232 now. Most computer manufacturers ask, well, what in the world would you need an RS-232 port for? Well, if you're programming PLCs, it's handy to have one. So you can come up with, if you don't have RS-232, you can come up with a RS-232 to USB adapter. Those are available from $10 to $30. And then you use a regular RS-232 cable from the USB adapter to the 232 port on the PLC. Okay, we have RSLinx open. Okay, now when we open up RSLinx, the first thing you have to do is configure a driver, because RSLinx all by itself has no drivers until you configure them. Here's a list a current list of drivers available in RSLinx. Now, these drivers are all aimed at the port on the computer, not on the actual device out there. You see they mention here PLC 5, SLIC 500, SmartGuard, and you see a couple PLC types mentioned, but these drivers are not drivers for those PLCs. They're for the COM ports on your computer. In other words, the COM port on your computer connects to the device out there by a cable. So by the time the information gets to the COM port on your computer, it better be in the right format to go across the cable and out to the actual device. So it just so happens that I had a driver highlighted here from something I was doing a little earlier. That's the driver you're going to end up using when you start working with the RSLogix Emulate 500. But for now, since we're talking about working with an actual hardware PLC, you would probably pick an Ethernet driver, either Ethernet devices or Ethernet IP. The difference between those two is that an Ethernet devices driver doesn't browse and look for IP addresses. You have to specify each IP address in the Ethernet devices driver. But the Ethernet IP driver is designed to allow you to browse a local subnet. So let's just say we're going to set up an Ethernet devices driver. Notice that all of these listed here are aimed at the device that's going to connect you to the actual equipment out in the field. Okay, so we now have a driver in RSLinx, and we'll just assume it was Ethernet, so we plug in an Ethernet cable. Okay, now what we have here is we have RSLinx, we have a driver, we have a cable. So we have a means to communicate from the PC to the PLC. We have a driver that can manipulate the data from any other application, whether it's Excel or RSLogix500. This RSLinx app will connect the software to the communications port on the PC. A cable connects that to the communications port on the PLC. So at this point we open up RSLogix, and in RSLogix we either open an existing project or we create a project. Once we have a project created, the next step is to take this project, and I've opened up RSLogix500 here. Actually it's RSLogix Micro Starter Lite, which is what you'll be using with a simulator. And if you look at this software, I have a little program there of no means, but over to the left in the project view you see the main folder is project, and under that is help, controller, program files, and data files. Now there's more files than that, but for the sake of our presentation here, the ones that we're concerned about are controller, program files, and data files. In program files you'll see there's system 0, system 1, and ladder 2. And I go through in depth in the manuals and in the lectures that go with the manuals explaining all these different files. But remember that we know that this PLC out there is a RSLogix 1000 because it's a piece of hardware. It has permanently embedded on the circuit board firmware that defines it as a RSLogix 1000. So the PLC already knows who it is. It just does not have any instructions. So we create this project that you see in front of you, and the project primarily for the PLC is data files and program files, plus some I/O configuration and other things under the controller folder. So we're going to take that project and we're going to send it through the RSLinx driver and then out to the PLC. So now the project exists in 2 locations. Actually probably 3. There's probably a backup on the hard drive, The project is open in RAM in your personal computer, and it's now downloaded out to the PLC. However, what's in the PLC is not ladder logic. It is machine level language. So what got downloaded was a series of ones and zeros, just binary values. But it's in the form that a microprocessor understands. So always keep in mind that most of this software, like RSLogix, RSLinx, RSLogix Emulate, they are written in a higher level language, and it has a man interface or man readable graphical user interface. And so it's presented to you in graphic form that you understand. But once it's compiled and then goes through the RSLinx driver and goes out to the PLC, it's a whole different story. So right here we have the typical scenario, RSLogix500 connected to a PLC by RSLinx. Remember, RSLinx is in the PC. It's not in the communications port, but it sets between RSLogix and the communications port. In the case of RSLogix Emulate 500, you're going to open up that software, and once it's in memory, basically that Emulate software replaces the PLC out there in the field. But the Emulate software is not a piece of hardware, so it is not manufactured as a MicroLogix 1000 or a MicroLogix 1100 or 1200 or 1400 or 1500. It's not manufactured as a SLIC 500, a SLIC 501, 502, 503, 504, 505. I think you get the point. It's just an open frame. So you have to define it. The simplest way to define it is to create a very simple project in RSLogix MicroStarter Lite with just the processor and the I/O configured. If it's a MicroLogix 1000, the I/O is fixed, so you don't have to configure any I/O. So you create a basic project, name it, and then save it. Once it's saved, then in Emulate software, RSLogix Emulate 500, you can open a folder, and when you do that, you're going to go look on your hard drive and find the file that you saved from RSLogix 500 or RSLogix MicroStarter Lite. You're going to open that, and that will be brought into the Emulate, and now the Emulate becomes a PLC. Now keep this in mind. A PLC, programmable logic controller, has a microprocessor and it has RAM. Your personal computer has a microprocessor and it has RAM. So the microprocessor in your personal computer now becomes the PLC's microprocessor, and a portion of the RAM in your personal computer is now replacing the RAM that was in the PLC. So this little framework down there called Emulate, once it knows who it is, in other words, I'm a MicroLogix 1000, that's sufficient. Now it's something that you can connect to from links. You can't go through RSLinx out through a cable out to something that doesn't know what it is, because it can't talk back. When you set up the driver with RSLinx, it sends out information. If it gets nothing back, it says, hey, there's nothing out there. So now you're going to connect up to the Emulate frame in your personal computer's RAM with RSLinx. So you open up RSLogix MicroLite, you bring in a project, and at this point, this looks exactly like what you would have out in the field if you had a laptop with RSLogix open and RSLinx open, a driver configured, and there was an actual PLC in a machine. You have yet to connect to that PLC. Even if you hook up a cable, until you actually go online or download or do something, you're not connected to that PLC. So in this case with Emulate, because the Emulate framework is now defined and has an address or a location number, 0 through 31. You can open up RSLogix. You can do communications, who active, and when you open up the browser, it will find the Emulate framework because it's made to appear now like it is a device out there on a network. And then you just go online with it. Once you're online with it, you can download a project from RSLogix into the Emulate, and you can upload from the Emulate into RSLogix. However, MicroLogix 1000 does not support online programming. And in the case of RSLogix Emulate 500, it does not support online programming anyway. So the only real difference between a PLC that you might have had out there to connect up to and Emulate is you will have to do all of your editing offline. Okay, step 1, downloading the software from Rockwell Automation. I'm going to take you through those steps. There's a link on my website, www.plcprofessor.com. It's a little hard to get to. I need to go in and fix that. But the easiest way is just to type in RSLogix500 Micro Lite or RSLogix Micro Lite into your search engine, search on it, and then scroll down until you see a link that is www.ab.com. Click on that one, and here you have a list of the software that's free for download from Rockwell Software or from Allen Bradley. We need 3 pieces of software. We need RSLogix Micro Starter Lite, we need RSLinx Lite, and we need the RSLogix Emulate 500. So the first one you're going to download is the first one on the list there under free starter programming software. RSLogix Micro Starter Lite without RSLinx for offline programming in English. This only comes in English and Chinese, so you got to be careful what you're downloading. Download the English version there, first on the list, and then go down after when that's done. Then go down to the third item, RSLinx Lite software. Download that. That file is 12 times larger, as you can see, so it's going to take a while to download. And then last but not least, you need the RSLogix Emulate 500. Once you have downloaded these, the next step will be to load them. And just in case you get there before I do, make sure you load RSLinx Lite first before you load the other 2. Now, in the old days, the order that you loaded software for Allen Bradley or Rockwell Software was always important, especially when it came to links. These days, that's not totally the case. I have run into some problems with Windows 7 where I loaded up the emulator first, opened it up, says, oh, that's right, I don't have the links, etc. And then I had problems. I went back and uninstalled them and then reinstalled them. So just for the sake of expediency, after you download these 3, load RSLinx Lite first, then the emulator, then the micro starter. Okay, this brings us to step 2. We just downloaded the software from Rockwell Automation, and we are going to load it on your computer. Now, all of my computers are Windows 7 64-bit. Some are Pro and some are Home Premium. When I first started looking at developing a simulator or developing a presentation to show you how to do this, I downloaded it on my Dell Inspiron i5 Tower, which runs Home Premium. And I loaded it up, everything worked great. So I figured, great. So I got my Dell i5 Inspiron laptop and loaded it up in the host, and it did not work so well. Now that was in Windows 7 Pro. So Pro has XP mode available to it, so I went on Windows Download Center, downloaded the 3 pieces of software I needed to run, virtual PC, XP mode, and there's one other thing, framework or something I can't remember now. But anyway, I ended up loading the software into XP mode and it ran fine there. So that's what we're going to use today. So I'm going to go down here to all programs, Windows Virtual PC, XP mode, and I'm going to open up XP mode. Okay, now that I'm in the XP mode, in a folder here called PLC Professor, trying to keep everything separate, I have the 3 pieces of software, and then I have the downloads in a separate folder. So we're going to open up RSLinx Classic first. And RSLinx is a driver manager. You can imagine that this is the same as the driver manager for your printers on your computer. We all use a word processor. We might use a spreadsheet, some publishing software. We have a variety of things that we use that we then print from. They all run in Windows, but we may send them at one point or the other to different printers. A Canon one day, a Brother the next day, an Epson the day after that. In my house here I have 3 printers, all 3 different brands. Each printer needs the information from the word processor manipulated into a form specific for that printer. It's printer drivers that do that. We've all loaded printer drivers. Okay? So when you open up printers and devices and you look, it will scan and it'll show you what printers are available. Each one of those requires a different driver. RSLinx does the same thing, except RSLinx connects between Rockwell software and devices out there. Now, those devices out there could be another application on the same computer, because you can connect up Microsoft software to Allen Bradley hardware out there. So RSLinx is what fits in between. So we'll open up configure drivers. That's the double-headed snake there. And you can see I already have a driver running. I'm going to delete that. That way we're starting from scratch. Okay? So again, you open up RSLinx, click on configure drivers, and if you looked around here you would think maybe there's nothing I can do but close or help. However, this is active, the little drop-down list. You should recognize this list from earlier in the presentation when I showed you the available device drivers that we could work with. So we talked Ethernet, but we're going to go down to RS500 Emulate. Click on that. We're going to click on Add New. Leave the default name. You could call this Monkey Business or Down on the Farm. You can punch any name in here you want, up to 15 characters. I always use the default name. So click on OK. Now, for this driver, this emulator driver, I am now defining who the laptop is. It's station 0, and I'll just put in my initials, TPG, and say OK. Now I have a driver that's created for the emulate frame. So I close this. Okay, now we go to RSWho, and you see there's our driver we just created. I expand it, and I'm the only thing there because we don't have anything else out there right now. So remember that RSWho is an application that runs inside of RSLinx. RSWho is not RSLinx. It's a separate application that allows you to browse your Linx drivers to see who's out there, or rather to say who the driver sees out there. So I'm going to close RSWho. I'm going to minimize Linx, and I'm going to open up RSLogix Micro English. Now remember, I explain that the emulate frame has no idea who it is until it can open a file and self-identify. So we're going to create something in RSLogix MicroStarter Lite. I'm going to go up to the upper left-hand corner, File, New, and I'm going to pick a MicroLogix 1000, and we'll just say OK. Hey, there's the whole project right there. So here's our controller files, our program files, and our data files. The data files go all the way down through N7. So let's create a rung of logic so we have something to look at. Now notice that this pane is blue, dark blue, and this one's light. That's because the focus for Windows is over here right now, not over here. So if I go up here and start clicking, nothing happens because the focus is over here and it ignores this. Click over here first, anywhere. Just click. Now the focus is switched over to ladder 2, the main program. Now I can go up here and drag down, hold down, drag it down till I see the Mimi. When it turns green, let go, that's a new rung. Or I can just click and it pops down. Or I can drag it down. See all the the red Mimis? In other words, these 3 red squares are all going, pick me, pick me, pick me. And whatever one turns green, and it won't matter whether you do this one or this one, because if I let go, output type instructions always go to the far right and conditions go to the far left. So here's a rung of logic, but no memory locations to execute with. So we go down to Input, down here under Data Files, double click, go to the upper left hand corner, click, lock it on top. Then move it down here out of the way, go down, double click on Outputs, lock it on top, and drag it over here. By the way, I go through all of this in extreme detail in the lab workbooks and the lectures that accompany the workbooks that you can buy on www.plcprofessor.com. Now, I want to give some memory locations to this rung. This is the input memory image right here, and this is the output memory image. So we'll go over to the input first. I'm going to put the mouse on I:0/0, hold the mouse button down and drag it over. Now see the 2 red Mimis up there? Well, I want it to go to this one. So when it turns green, drop it. Then I'm going to go grab the first bit from my output word, bit 0, go up, when it turns green, drop it. Now I have a complete rung. However, the E's signify that no one has verified this rung. So I'll go up here to this button right here. It looks like a little computer with a green check mark. I'll click on that and it verifies the whole project. If anything was amiss, wrong, incorrect, at the bottom of this application a little error window would pop up and it'll tell you the errors so you can go fix them. So we have a rung of logic, everything's good. Now I'm going to save this. File, up in the corner, Save As, and I'm going to save it in my folder that I've reserved, and I'll call this First Try. Save it, and then I'm going to close RSLogix MicroStarter. Now I'm going to go open up Emulate. Okay, I'm going to open up this empty framework. You see up here, you drop down, there's nothing there. I mean, this not only doesn't this emulate frame know who it is, it doesn't even know where it's at right now. So this thing is just a big blank. So this emulate frame is going to be your PLC that you're going to program and run and work with. So we have to let it know who it is. Remember, we just created a project in RSLogix MicroStarter Lite and saved it to the hard drive. So we're now going to go to that location, the folder you saved it in, click on it and say open. Now Remember, you saw something that didn't have this much detail, but it was similar when you did the Emulate driver, where you identified that your laptop was station 0. You can identify this as station 1. Now it could be anywhere 1 through 31 at this point. You've already used 0, so you can make this 31 or anything down to 1. We'll make it 1. We'll leave the rest of this alone for right now. Click on OK. You now have a RSLogix 1000 running in the RAM of your computer. So let's go back here now. Now see, if you look down here, you see you got Linx running and the Emulate running. Now let's go back to RSLogix. Okay, we'll do couple different things here. I'm going to click on Comms, System Comms. Click on the driver. There's our RSLogix. I'm going to go online. Okay. Now there we are. We are online. You see this little ladder logic thing swirling up here? When you see that spinning like that, or you see color over here, you are online with that Emulate frame, or you're online with a real PLC out there. In this case, it's the Emulate frame. I can click here next to Remote Program and put it in the Run mode. Are you sure? Yep. Now watch the output memory location over here when I toggle this on. So I'm going to right click here, go down and toggle bit. You see that one on? Right click here, toggle bit. Now you see it went off. Now let's go put this in the program mode. Are you sure? Yes, go to program mode. Now I'm going to right click here, and you see this bit goes on to memory, but this one doesn't, because it's not executing the logic. However, if I put this back in the run mode, yes, go to the run mode, that instantly goes on because this bit was on. So this instruction is true, so it turns that bit on to memory. Now I'm going to go offline. It asks me if I want to save my changes. Yes. Upload. Yes. Okay, now we're offline. And it shows these bits as on, but remember, we have two things going on in the RAM of our laptop right now. In one area we have RSLogix500, and it has a copy of the data table, and it shows these bits as on. And then we have another chunk of RAM set aside for the Emulate frame, and that's separate. Okay, so if I toggle this off, I just toggled it off in the RSLogix Micro Starter Lite database, not in the database down in the Emulate frame. Okay, that's beside the point. Let's just change the logic, and we'll delete that, and I'll go to up here and put in a timer. You haven't done all this yet, so don't worry about following along. I'm just creating a 3-second timer, and let's put a branch around it, and let's use a bit to turn on something. So we'll use the timer bit, T4:0.dn, which means the timer's done, and we'll do our output bit here that we had before. Okay, now I'm going to go up here and verify this. It's a happy rung. Now I'm going to download this to that Emulate frame. Remember, that Emulate frame right now is running at a whole different rung. So I'll go up here to Comms, System Comms, click on our our RSLogix 1000, download. This always comes up. I just say yes. You want to go online? Yes. Okay, I'm online now. Do you want to run? Go to run. Are you sure? Yes. Now let's toggle this on. See the timer's timing up. When it hits 3 seconds, that goes on. If I toggle this off, the timer resets. Watch it again. Watch the accumulate over here, the done bit, and the output that it's controlling. So we'll toggle that on. You can see it accumulating in hundredths of a second. When it's done, it turns it on. Okay, so there we are. We're simulating a RSLogix 1000. This will also work for an 1100. 1100 supports more features. So actually this is more powerful than using the $125 RSLogix 10.io brick. However, it's not quite the same thing. It's always nicer to have a real PLC with switches or sensors that you can write a program and then you can control it from the switches. In a later session, I'll show you how to do the same thing with debug files, where you can actually simulate your machine. So when you turn on something, the debug file then runs logic that sends something back that says that what you wanted to do is now done. So it simulates an actual process. Thank you for watching. As always, it's a pleasure to make these videos. This one was not rehearsed. I just had some time. I wanted to get this on the YouTube channel right away because I know there's a lot of people that are wanting to learn to program a PLC, and using these three pieces of software together is kind of a struggle until you realize what you're doing. Then of course it's a piece of cake. The only revenue that gives me any support in making these videos is from the sale of those electronic PDFs on the PLCprofessor.com website. So I appreciate it that you don't pass the files around to your friends and other people who want to learn. The price of those three manuals in electronic form is, I made it as inexpensive as possible, so it would not inhibit anyone from learning. Now you have the simulator, and I may redo this video once I've maybe done a simulation for an 1100 and maybe added some more documents for the manuals specifically for instructions that the 1100 supports that the 1000 does not. So once again, thank you very much for watching and enjoy.